Okay, so we know work done is equal to force times the distance. So the force in this case is the gravity of the person, which is mg, and the distance here is the height difference, because the person is starting at an elevation of 2800 meter. Okay, so therefore we know the mass for the hiker is 65 kilograms, and the acceleration of gravity is 9.8 meter per second square, and the height difference is the top of mountain minus the elevation point, which is 4200 meter minus 2800 meter, and this give us 1400 meter. So therefore the work done should be equal to 65 kilograms times 9.8 meter per second square, and then times 1400 meter, and this will give us the work done is about 8.92 times 10 to the power 5 joule. And for the power, we know the power is equal to work done divided by the time interval. So since it takes the person 4.6 hours to climb to the top, so therefore we know 4.6 hours is equal to 16,560 seconds, because in 1 hour there are 3,600 seconds. And we know work done from the last question, so therefore we can determine the average power, which is equal to 8.92 times 10 to the power 5 joule over 16,560 seconds. And this will give us the power is about 53.86 watts. And for the last question, well, we know that the efficiency rates is 15%. Okay? And the efficiency rates can be equal to the power over the input power times the 100%, which also can be equal to the work done over the energy input. Okay? Because as you can tell here, so we have W over delta T over U over delta T. As you can tell, delta T can be cancelled out. So therefore, this is also equal to work done over the energy input. Okay, so therefore have power over the input power is equal to work done over the energy input. So therefore, the input power is equal to power times the energy input over work done. And since we know work done over the energy inputs is equal to 15%. So therefore, work done should be equal to 15% of energy inputs, which is 0.15 U. So if we plug in back to the equation, we have input energy, which is P in here, is equal to PU over 0.15 U. So therefore, U cancel out. So input power is equal to the power divided by the 0.15. So we know the power is 53.86 watts. So now we can determine the average rates for the power inputs, energy inputs, okay, which is the input power, and this is equal to 53.86 watts over 0.15, and this will give us the rate of energy inputs is about 359.1 watts.